Hey guys, welcome back. We got one more lesson before we start trig, which is going to be probably the most important part of the entire right triangle unit. We'll spend like 5 days on trig too, so inverse trig, doing all kinds of fun stuff. So we'll start that tomorrow, which you'll get it before the weekend, which is pretty exciting. So before we start trig, we need to remember our special right triangles. So the special right triangles the one that we had yesterday was a 45, 45, 90 special right triangle, SRT. And a 45 degree angle tells us that it's going to be isosceles, right? So this is isosceles right triangle. So these two sides, we let them equal 1 to make it like the most simple special right triangle we could have, right? So if it is a right triangle, then we know the Pythagorean theorem holds, right? And we can find the missing side lengths, the hypotenuse, by doing the Pythagorean theorem. If you remember, it was 1, 1, and radical 2, right? Hopefully you remember that from yesterday. Anyway, so plug it in. Our two legs are 1 and 1. 1 squared is 2. And then this we change to an x squared because that's our hypotenuse length. And so we have x squared is equal to 2. But we don't want x squared, we want just x. So we have to undo a square with the square root. So we take the square root of both sides. And then we get x is equal to the square root 2. So that was our missing side length. So 1, 1, radical 2. Now we know the extended proportion of all these side lengths here is 1, 1, radical 2. And that actually tells us the ratio of any of the sides. So it's either a ratio of 1 to 1, these two sides, or one of the legs and the hypotenuse, which would be a ratio of 1 to 2. So this information here actually tells us all about the lengths of the sides and the angles, technically, for a 45 right triangle, which is what trig is. Trig is basically just the ratios for a right triangle, it's just going to be the ratios of the opposite and the hypotenuse or the adjacent lengths, which we'll get into tomorrow. Pretty exciting. So if we want to scale this one up by a scale factor of 2, then the radical 2 is just going to become 2 radical 2, right? Just like when we blew up, you know, the poor innocent puppies or that poor guy on Veterans Day, if you remember. That was fun. It's like our first day back. Oh, good times. See, I even still we have fond memories from this year, even though we've only seen each other in person, what, like 12 times? But it's okay. Trying to make the best of the situation. So times 2. 1 times 2 is going to be 2, and then 1 times 2 here is also going to be 2. So we have now 2, 2, and 2 rad 2, which is the same extended proportion or extended ratio because we can reduce it down to 1, 1, and radical 2. So if you notice, the ratio of the sides is exactly the same for all 45, 90 right triangles. And so the only question we have is how much bigger or how much smaller, or what is the scale factor to 1, 1, and radical 2. And that's what the whole purpose and the power behind trig is. We know what one of the triangles, the side lengths of one of the triangles, then we know the scale factor, and then we can find the length of all the other sides. So that's really the power of trig, which is pretty cool. So our new one, the only other special right triangle we have is a 30, 60, 90 special right triangle, which actually comes from half of the equilateral. So if you remember equilateral triangles, it means all the sides are the same, which means their opposite angles are all the same as well. And if they all add up to 180 degrees, then that means all of them, of course, I hope you know by now, they all have to be 60 degrees. So it's not a 60, 60, 60 right triangle because that's not a right triangle. So where do we get the right triangle? Well, just cut it right down the middle. So if I cut it in half, then it's going to bisect this angle, cutting in half, which is now going to be 30 degrees. So we have our 30, our 60, and then, surprise, surprise, our 90 degrees comes from our perpendicular diagonal, which is also an angle bisector. All right, so we basically have 30, 60, 90 here. It's going to be half of an equilateral triangle. Then the only question is, what are the lengths of the sides? So what do we know about the sides of an equilateral triangle? Well, all the sides are equal. Okay, and then if we cut this one in half, we bisected it. Let's let this length here be 2. Well, if this length is 2 of our equilateral triangle, this side's 2 as well, and then the whole bottom is 2 as well. And then for the 30, 60, 90, it's going to be cut in half by this drop perpendicular. We've done that a few times before. You can see that these two triangles are congruent by angle, angle, side, by reflexive property. You can also do angle or side, angle, side. There's so many different ways to prove it. We've done it a million times, right? So this side is 2, so this side here is going to be 1 because it was cut in half. It was a perpendicular diagonal bisector. And then the only question we have is, what is the height of this equilateral triangle? Well, since it's still a right triangle, we can solve that, again, using the Pythagorean theorem. So the only difference is this time our hypotenuse is what's been one of the things that's been given to us. So we have a leg and a hypotenuse. We're solving for the other leg. So what I want to do when I plug this in is it's going to be 1 squared plus x squared is equal to 2 squared. So it's a little slightly different. And we solve it not by adding them together, but now we're actually going to have to subtract the 1 squared from both sides. So that's going to leave me with x squared is equal to 2 squared minus 1 squared. Well, 2 squared is 4, 1 squared is 1, so 4 minus 1 is 3, right? So I have x squared is equal to 3, but I don't want x squared, I want just x, so I take the square root of both sides. So that leaves me with x is equal to the square root of 3, which is just radical 3. And that's already a prime number. The 3 is prime, so it can't be broken down, and we're done. We're simplified. So we have 1, 2, and radical 3. So this one here is going to be radical 3. All right, so it's kind of easy to remember because you have 1, 2, 3, like 1, 2, 3, 1, 2, radical 3. Now the confusing part, and I'm going to go ahead and address this right now, I'm going to pull up my calculator, is that radical 3 is actually smaller than 2. Okay, 2 is the hypotenuse, that's the longest length. So if we look at radical 3, the square root of 3, it's going to be about 1.7, all right, 1.73, which is less than 2. And if you think about it, if we wrote 2 as a radical, 2 as a radical would be the square root of 4, right? So over here, oh, and 1, by the way, is also the square root of 1 is 1. So we have the square root of 1, the square root of 3, and the square root of 4. So obviously the square root of 3 is going to be smaller than the square root of 4, which is 2. And well, like we just saw, the square root of 3 is approximately 1.73, which is smaller than 2. Okay, so if we're writing this out in order, it's going to go at 1, radical 3, and then 2. That's the order from least to greatest. Don't forget that. The hypotenuse is the 2, right? That's how we got the half length of 1, and the only thing we had left to do was find the height, which is radical 3. Okay, so that's important because it's the most common mistake that I already know I'm going to see. Okay, so we have 1, 2, and radical 3. And again, remember that's not in order. I'm saying 1, 2, radical 3 because it's easy to remember 1, 2, 3, but remember radical 3 is smaller than 2. Okay, so if I'm going to scale it up by a scale factor of 2, then 2 would now, the hypotenuse length of 2, the longest side, is now going to turn into the longest side of 4. 1, which is half of that length of 2, is going to be half the length of 4, which is now 2. Okay, no big deal. And then radical 3 times 2 is now going to be 2 radical 3. Now that was with a scale factor of 2, so this was an enlargement, and we can really multiply it by any scale factor, not just 2. We could also multiply it by 3, 4, 5, 2.5, 2.6. It doesn't matter, any number that's larger than 1. So instead, if we wanted to multiply it by a scale factor of 3, we do that. So the longest side of 2 is now going to become 2 times 3, which is going to be 6, the longest side of 6. Half of 2 is 1, so half of the 6 is going to be 3. Okay, and then you can also do 1 times 3, which is still going to be 3, and then radical 3 times 3 is 3 rad 3. So notice all of these are getting larger, okay, and there's infinitely many. We can keep going. I just run out of space. We can do times 4, times 5, and you can imagine what that would look like. Eventually we run out of space, right? But there's also infinitely many that exist where they're getting smaller. So we could scale it down by a scale factor of 1/2, okay? So then this would be like k is equal to 1/2, right? So half of 2 is 1. And then half of 1 is going to be half of this one as well, right? Which is 1/2, and then radical 3 divided by 2, right? Now there's even more. We could do it by 3/4 or 5/6 or any number that any fraction, proper fraction that we want, right? Or even a decimal. And there's more, right? It goes all the way back, and there's infinitely many of them. They just keep getting smaller and smaller and smaller. And there's infinitely many of them as they go all the way back to 0, right? Which would be like shrinking it down to, like, instead of Honey, I Blew Up the Kids, you could do Honey, I Shrunk the Kids. Okay, but you don't catch that reference because I'm pretty sure that movie came out. They came out in the 90s, but so did fanny packs and tie-dye shirts. And what else did you miss? The Earth, we always knew it was round. You guys messed that up. My generation didn't eat Tide Pods. We were too busy doing other dumb stuff that I'm not going to tell you about because you haven't figured it out yet. Okay, so anyway, there's infinitely many enlargements that we can do. There's also infinitely many reductions we can do as well. All right, and all of these are similar triangles. They're all similar to each other. The only question is how much bigger or how much smaller does it get? But they're all similar to the ratio of 2, 1, radical 3. 1, 2, radical 3. All right, so if we have a 30, 60, 90, similar to this one, right? So it's got to be either a blown up or a shrunken down version of it. And if we line up the parts, so opposite of the smallest angle is our smallest side of 1. Opposite the smallest angle of 30 is going to be opposite the smallest side. So we know the 1 goes with the 3. So what was our scale factor? 3 divided by 1, which is times 3, right? So what is the 2 going to turn into? Well, 2 times 3 would now be 6. And you also know it's just going to be twice the smallest side, right? And then radical 3 times 3 is going to be 3 radical 3. All right. So that's pretty easy. Now, it can be a little bit harder, which is when we go from a radical to a regular number or a whole number. So notice here it's opposite the medium side length, which is 60. Opposite the medium side length of 60 is going to be the 12. So the radical 3 goes with 12. Not the 2 goes with 12 or the 1 goes with 12. That would be easy because then our scale factor would just be 6 or 12. Don't just do the easy thing. You got to make sure you line it up. Medium side opposite the medium angle, medium side opposite the medium angle. So radical 3 goes to 12. Okay, how do we go from a radical to a regular number? So how do we go from rad 3 to regular 3? Well, we need to multiply it by rad 3. So rad 3 times rad 3, or rad 3 squared, is radical 9, which is the same thing as a regular 3. Okay, so now we have a regular 3. How do you go from a regular 3 to a regular 12? Well, we still have to multiply it by 4. So altogether, our scale factor is going to be 4 radical 3. So radical 3 times 4 radical 3 will get us to the regular 12. All right, good. So if that's our scale factor, we got to multiply everything else by it too. So 1 times 4 rad 3 is just going to be 4 rad 3. And 2 times 4 rad 3, we multiply the parts in front of the radicals, which would be 8 rad 3, right? All right, so that's pretty much it. It can't get any harder than that. So let's go ahead and start the assignment. We're flying through this stuff. Good stuff. All right, so I've got my hypotenuse over here, which I know if this is 30, 60, 90, has to be the longest side is 2, the smallest side, opposite smallest angle is 1, and then opposite the medium angle is going to be the radical 3. So if I'm going from my hypotenuse of 10, or hypotenuse of 2 to a hypotenuse of 100, I'm multiplying it by a scale factor of 50. So what is the 1 going to turn into? Oops, let me do that. Well, 1 times 50 is going to be 50, right? And that would be your answer because you just have to solve for the value of x. All right, number 4. This one can be tricky because which one's the longest side? Is it this one or is it this one? The one on the right or the one on the bottom? How do you know for sure? All right, well, the opposite of the right angle is our hypotenuse, so our longest side is going to be 2, which is on the bottom here. It's very common for you guys to mix that up because you're used to me putting the bottom right angle being the right angle, right? But they can be oriented however you want. So the medium angle is going to be the radical 3 opposite the 60, and the smallest angle of 30 is opposite the smallest side of 1. So make sure you got that down. And remember, 2 is the longest side because it's half of the equilateral triangle gives us the 1, and the radical 3 is the height of the equilateral triangle. Okay, so if I'm going from a hypotenuse here of 2 to a hypotenuse here of 36, and it's a 30, 60, 90, so we know they're similar by angle, right? I'm multiplying by 18 in this case. So to find x, that's the 1. What's 1 times 18? Oh, that's easy. It's just 18. Okay. All that just to get 18? Okay, whatever. Oh, yeah. And by the way, if this is a 30, 60, 90, don't you know that this side has to be half of 36, which is 18? Duh. Okay, so there are some shortcuts, but in general, I want you to see the scale factor and set it up that way. Okay? All right, number 7. Classmates said that the perimeter of a 30, 60, 90 right triangle can never be a whole number. Is that true? All right, so if we look at our original one, the 1, 2, radical 3, if we find the perimeter, we add them all up. So 1 plus 2 is 3, plus a rad 3 is just 3 plus rad 3. We can't add those together. That's not radical 6. It's not just 6. It's 3 plus radical 3. They're not like terms. We can't add them together. Now, if I wanted to try to get rid of this radical 3, right, so that they're all whole numbers, well, I would have to multiply it by the smallest number would be radical 3. So rad 3 times rad 3 is now regular 3. All right, so I was successful. I got rid of this radical for the medium side. But now when I multiply everything else by the radical 3, 1 times rad 3 is now rad 3. 2 times rad 3 is 2 rad 3. Now, instead of having one radical, now I've got 2 radicals. It's just going to be a trade-off. You either got 1 or 2, or maybe even both if we multiplied it by a different radical, but that wouldn't be very helpful. Like if I multiply by radical 2. No reason to do that. All right, so if I add all these together, radical 3 plus 2 more radical 3s is 3 rad 3, plus the 3 is going to be 3 plus 3 radical 3. All right, so either way we have it, it's never going to be a whole number. We're always going to have a radical component for the perimeter of a 30, 60, 90. Kind of cool. All right, number 8. So we have an equilateral triangle that has an area or a perimeter of 120. So if it's an equilateral, then all the sides are the same. So 120 divided by 3 would be 40. So the whole base is 40. So what's the length of half of that, which would give us 20, right? So we have our similar one over here. We have the longest side of 2, shortest side of 1, and then radical 3 is our height. So in order to find the area, we have our base of 40, right? We need to find our height. So I need to know what this length is here. Well, what's my scale factor if I'm going from 1 to 20? Well, I'm obviously multiplying by 20. So what's going to happen to radical 3? It's going to be 20 times rad 3. So we got 20. This side here, of course, is 40, and this is 20 rad 3. So now use your formula, base times height divided by 2. Well, our base is going to be 40 times our height of 20 rad 3, which is going to be 800 rad 3, then divided by 2, which will give us 400 radical 3, which will be your answer for the area. All right, number 9. So we would normally use compasses on this one, and it's pretty fun, but because you guys don't have compasses, I just constructed it for you. So for instance, if we want to do 5, 10, and radical 3, I'm going to take this length here. Actually, we'll do 3 instead because it's the only green one. There we go. So we're going to do the green one, and let me change my color here to green. And so what we would do is we draw an equilateral triangle. So we have a length of 6 here. So I'm going to draw my arc going up, and then I'm going to do the same thing from the other side. Well, I guess I can show it like that. But yeah, do the same thing from the other side. And obviously I'm not doing this perfectly because it should match up. But where those cross here, that would be the length. If we have this going up here, that length is going to be, we got 3 on this side. You can see that. So we got 3. And then this would be 3 radical 3, and then this length here is 3 plus 3, which is 6. So we have 3, 6, and 3 rad 3. That's kind of busy, but you get the idea. All right, so that's why I just drew it over here. So this measurement here should be 3 radical 3, which is approximately equal to 5.2. And if we look here, it's about 5.2 because it's between 5 and 6. So that's exactly right. So that's technically how we would do that if we were doing it with the compasses, but because we're not in class, because of Snowmageddon and all that stuff, I just drew it for you. Okay, cool. All right, so looking at, we have here 1 radical 3, and this side length here is 2. And so that should be radical 3, which is approximately 1.73. All right, and it is about 1.73. And then 2 radical 3, we're just scaling it up times 2. We went twice as far out here. So that's 2 rad 3, which is approximately 3.46. And if we look here, it looks a little bit more than 3.5, or a little bit less than 3.5. So maybe it's off by a little bit, but that's okay. We already did the 5.2, and then 4 rad 3 here would be approximately 6.9, which is a little less than 7. And then 5 rad 3 is 8.66. That's dyslexia, my bad. All right. Anyway, which is just a little bit more than 8.5. Okay, cool stuff. So you can actually see this, like, it's physically on your paper. Well, physically on your paper on your iPad, but you get the idea, right? It's pretty stinking cool. And if we could do this with compasses, it would be even more cool. But you know, I'm gonna be happy with what I got. All right, so make the most of the situation. It's really cool. This stuff actually works. You can see the radicals as we grow, as we increase it, multiplying it by times 1, times 2, times 3, times 4, just like we have here, except it's physically on your own piece of paper, and you can measure it with a ruler and a compass, and it's just fun. Geometry is fun. It's like this stuff's real. It's not just like in my head. Like it's on your paper and it's real. All right, number 10. Line them up. So I drew one that's similar to it, and this is like our scaled down or scaled up version. Our longest side opposite the biggest angle is 2, smallest angle, small side 1, and then radical 3 is going to be our medium angle. If I'm going from a hypotenuse of 2 to a hypotenuse of 20, I'm multiplying it by 10. So if I want to do the x, that's going to be 1 times 10, which is just 10, right? And that's half of our hypotenuse anyway. And then our medium side length is going to be radical 3 times 10, which is 10 rad 3. So you got 2 answers on the answer bank there, 10 and 10 radical 3. You can cross them out. Number 11, again, orient them. Make sure you have it go in the right direction. Notice that the radical 3 is, that's the medium length, right? The longest one is the 2, which is on the bottom, so it's upside down. Just be careful. So if I'm going from 2 to 14, I'm multiplying it by 7. So radical 3 times 7 is just 7 rad 3. 1 times 7 is just 7. So we have 7, 14, and 7 radical 3. All right, on an equilateral triangle, it says the height is 24 centimeters. What's the length of the side lengths of the triangle near a centimeter? All right, well, the height on our scaled down version one is going to be radical 3. So how do you go from a radical 3 to 24? So the first part is, how do we undo the radical? How do we go from a radical 3 to a regular number, like regular 3? Well, we have to multiply it by radical 3. Then once we have radical 3, that's going to be a regular 3. And then how do you go from regular 3 to 8? Well, you have to, or to 24, you have to multiply by 8. Okay, so 8 radical 3 is going to be your total scale factor. So what is the regular length going to be? Well, the bottom here is going to be 8 rad 3, but what's the full length going to be? Well, that's going to be 16 radical 3. All right, kind of a tricky problem because you got to do that part, but hey, what a cool problem. All right, number 19. Now these are kind of composite problems because we have two special right triangles. Over here we have 45, 45, 90, which if you remember is similar to 1, 1 radical 2. Then over here we have a 30, 60, 90, which is similar to 1, 2 radical 3. Remember, the longest side is 2, opposite the hypotenuse. Longest side is radical 2, opposite the hypotenuse. So you can see the similarities between two. All right, and they're all similar. It was like a pun. Get it? Because look, they're similar. These two are similar, and these two are similar, but yet they're even similar in the radical 2. And I know. Mind blown. Okay, so how do I go from radical 2 to 12 rad 2? Well, I'm multiplying it by 12. So what happens to the 1 and the 1? Well, they become 12 and 12. All right, so there's two of your answers. And now I can solve this one. So if I'm going from 1, our shortest side length of 1, to our shortest side length of 12, I multiplied it by 12, just like I did over here. It's kind of cool. It's like the whole thing is like being blown up together as this one big 12 times, and put them together, and it's fun. All right. So what happened to 2? 2 times 12 would be 24. Radical 3 times 12 would be 12 radical 3. All right. Cool beans. All right, number 21. This one's a little tricky, so I'm going to do it with you. We got 60 degrees, so we got a little 30, 60 degree, 30, 60, 90 here, which is similar to this one. Medium angle, medium side, biggest angle, biggest side, smallest angle. All right, so we got it all lined up. How do I go from a hypotenuse of 2 to a hypotenuse of 10 radical 3? Now, you might originally want to go radical 3 to 10 rad 3 because it's just times 10, but you got to line them up, right? The hypotenuse to the hypotenuse, so 2 to 10 radical 3. Well, first, how do we go from 2 to 10? We have to multiply by 5. But we're not just going from 2 to 10, we're going from 2 to 10 rad 3. So we got to multiply by 5 radical 3. So what is the 1 going to turn into? Well, 1 times 5 rad 3 is just going to be 5 rad 3. What does the radical 3 turn into? Well, the radicals are going to undo each other, so that's going to make it a regular 3. Regular 3 times 5 is 15. All right, so we have basically a height of this trapezoid of 15. So what's the length over here? Well, if this is a rectangle, and it is because right angles, it's got to be 15 as well. All right, so we got 15 and 15. The only other thing we got to do is solve for b. Well, b is not 30 because 30 is the whole thing if you follow the measurement line. But we don't want that part of it. We just want this part right here, that part. So I'm going to do 30 minus 5 radical 3, and that'll be my answer. It's just written as an expression, a radical expression. We can't combine these. It's not 25 rad 3, anything like that. It's just 30 minus 5 rad 3. All right, and that's it. That's the last question I'm going to do with you. 25 minutes, not too bad. Let me know if you guys have any questions. This is really the precursor to trig, so we're almost there. Tomorrow we're going to start trig. I'm super excited. Let me know if you guys have any questions. I'll see you guys later.